is a totally new way that the ocean could get screwed up. Well, I guess it's not totally new, but changes in ocean currents could destroy the planet, new study suggests, published July 8th. A new study published this month highlighted the growing dangers of changes in the ocean currents. Weaker circulation in the ocean currents could actually enhance the amount of buildup in CO2 in the atmosphere, speeding up the destruction of the planet by increasing global temperatures. The changes in the ocean's overturning circulation are also tied to climate change advances. So it's kind of like a circle of life type of thing. The slowdown, scientists predict, could mean less pull down of carbon dioxide from the atmosphere by the ocean. However, they also predicted that it could mean less carbon dioxide is dredged up from the bottom of the deep sea. As such, scientists believe that there could be a balancing effect, but that might not be the full story. In fact, the dangers of the changes in ocean currents are still very real, according to a new study. The new research was headed by MIT researchers and published in Nature Communications. While things appear to remain balanced to some, as the circulation continues to slow, it may actually release more of the carbon stored at the bottom of the deep ocean. This, of course, spells bad news for us, as carbon dioxide is a greenhouse gas, and that means that it will ultimately help trap more heat in the Earth's atmosphere. A subsequent result of that will be continued rising of global temperatures, possibly thawing of ancient ice shelves, and rising sea levels that could decimate the coastline of countries worldwide. And I don't know if you guys saw what the government put out of what the East Coast is supposed to look like in the next 20, 30 years. But they had all these states that they listed out. I can't remember which ones, but the Northeast, some of these states are going to lose 30 or 40% of their landmass in the next 20 to 30 years. Where are all these people going to go? Remember when we talked about the fact that borders can be sprung up within our own border internally, and that can just be done willy-nilly, and that with surveillance technology and stuff like that, it's a lot easier. Well, what are we going to do whenever we lose Miami, Philadelphia, New York, Boston? Who knows? I have that's just a couple of big cities right there, but what are we going to do whenever those cities are underwater and we have tens of millions of people that are trying to migrate across the nation? And I saw the effects of Katrina, and they had told us that we have to spread out the refugees of Katrina from New Orleans and all of Louisiana, because one state could not take the refugees because it would be a burden on the economy. So we had to spread them out to all these different states. And that was just a couple 100,000 people. If we're talking about tens of millions of people, it's just it's hard to even imagine, and I can let you imagine it. But rather than getting down and out and upset about it, just realize that all of these people are going to be ready for change, and that this is just more and more people that are ready for real change, and we're getting closer to it. We're not getting further from it. We're getting closer to real change, and that's kind of what I was talking about with the disaster movie, of making our own narrative and kicking out these Hollywood writers, so to speak. I mean, we know that we're just speaking hypothetically or whatever, rhetorically, but we can make our own way in the future with these technologies, and our own cooperation collectively. By all working together, we can get our ethics spoken for and save the planet, basically. So I just wanted to say that. But the reason this new study believes that the changes in the ocean current could actually cause more dredging of the deep ocean carbon is because of the overall balance between iron, carbon, nutrients, surface microorganisms, and the class of molecules known as ligands. The dangers of slowing ocean currents all come into play because slower currents mean fundamental changes to these key players and the amount of carbon they also release into the ocean. Ultimately, this means that the ocean outgasses more carbon back to the atmosphere the researchers say it will completely overturn what we thought was going on with the ocean, and that we need to be proactive in finding ways to cut the emissions now so that we can buy more time to mitigate the climate change issue. So that's pretty heavy. Anytime a scientist says it completely overturns what we thought about what was going on, I love that sentence. And how many times have I read that on this podcast? This got to be like the 8th time, if not like a dozen times that we've read that sentence, and I love it. Every time you hear that, it's a total reworking of people's minds and the way that they think. And that's evidence that we're changing. Like, that's what I'm showing everybody here, for us to carry on. You know, and as well, they talk about Native people having ancient traditions or oral traditions, and that they're cast on, these narratives are passed on verbally. There may be a time where we do not have access to news resources the way that we're presenting them today, that I've collected and presented this to you guys, and the way that we all can just look up anything on the internet. We might not always have that, but you will have these lessons basically that I've put into this podcast, and you can tell other people that, and as long as you remember them, basically nobody can take that from you. So we have our own oral tradition, basically, and our own narratives that, should anything happen, you can remember, like, oh, well, I learned this, and we can do that. Or just the idea of it. That's just kind of how I feel. I hope other people can see what I mean with that. But we'll talk about the positive now. So, new carbon storage technology is the fastest of its kind. University of Texas, Austin. And it's got a little infographic here. And it shows a factory on the beach, on the land. It says CO2 hydrate production. And then there's like a pipeline coming up out of the ocean. It says hydrate transport. And then some facilities underwater, compaction and sealing of hydrates. And then on the bottom right, further under the ocean, it shows sequestration, which is them putting the carbon into the ocean. A new study to store carbon captured from the atmosphere, developed by researchers at the University of Texas at Austin, works much faster than current methods without the harmful chemical accelerants they require. In new research published in ACS Sustainable Chemistry and Engineering, the team developed a technique for ultra-fast formation of carbon dioxide hydrates. These unique ice-like materials can bury carbon dioxide in the ocean, preventing it from being released into the atmosphere. We're starting a huge challenge, finding a way to safely remove gigatons of carbon from the atmosphere, and hydrates offer a universal solution for carbon storage. For them to be a major piece of the carbon storage pie, we need the technology to grow them rapidly and at scale, said Vibhav Mahadur, a professor at the Walker Department of Mechanical Engineering who led the research. We've shown that we can quickly grow hydrates without using any chemicals that offset the environmental benefits of carbon capture. Carbon dioxide is the most common greenhouse gas and a major driver of climate change. Carbon capture and sequestration takes carbon out of the atmosphere and stores it permanently. It is seen as a critical aspect of decarbonizing our planet. Today, the most common carbon storage method involves injecting carbon dioxide into underground reservoirs. This technique has dual benefits of trapping carbon and also increasing oil production, which makes no sense because you're taking carbon out and putting carbon in. You're probably taking more carbon out, whatever. That's a whole rant. But yeah, I guess you do get more oil from doing that, but it's kind of redundant. However, this technique faces significant issues, including carbon dioxide leakage and migration, groundwater contamination, and seismic risks associated with the injection. Remember when I was talking about how we're having more and more earthquakes, and our continent is being broken up into microfractures by these pressurized injections. This is what I'm talking about, or just part of what I'm talking about. I don't think it's a good idea at all. And it's the oil companies doing this. And it's just another example of them screwing up the planet. Like, they've screwed up the whole carbon cycle, and now they're literally like dissolving the continent into dust. The continental plate that we live on. It's just fracturing it all into, what will, maybe dust is a hyperbole, but hydrates represent a plan B for gigascale carbon storage, Bahadur said, but they could become plan A if some of the main issues can be overcome. Until now, the process of forming these carbon-trapping hydrates has been slow and energy-intensive, holding it back from becoming a large-scale means of carbon storage. In this new study, the researchers achieved a 6-fold increase in the new hydrate formation rate compared with previous methods. The speed combined with chemical-free process makes it easier to use these hydrates for mass-scale carbon storage. Magnesium represents the secret sauce in this research, acting as a catalyst that eliminates the need for chemical promoters. This, aided by high flow rate bubbling of CO2 and rate-specific reactor configuration, this technology works well with seawater, which makes it easier to implement because it doesn't rely on complex desalination processes to create fresh water. Hydrates are attractive carbon storage options since the seabed offers stable thermodynamic conditions, which protects them from decomposing. We are essentially making carbon storage available to every country on the planet that has a coastline. This makes storage more accessible and feasible on a global scale, and brings us closer to achieving a sustainable future. The implications of this breakthrough extend beyond carbon sequestration. Ultra-fast formation of hydrates has potential applications in desalination, gas separation, gas storage, offering a versatile solution for various industries. The researchers at UT have filed for a pair of patents related to the technology, and the team is considering starting a startup to commercialize it. And we're going to continue on with some good news here, that researchers achieve mind-blowing breakthrough with new heat-to-energy converter, and it could change electricity. So as I'm reading about this, I kind of want you guys to think about the quartz water crystal energy storage, that it was saying that it was storing heat and that it was highly effective and that they just needed a way to convert the heat to electricity. Well, here's the heat to energy converter that they needed, and it's got pretty high efficiency rate. It's not perfect, but it's pretty high, and I'm sure that it will be worked on continuously. So it's interesting how whenever you start becoming a learner and you just start studying a lot of these really breakthrough topics, and they kind of are repetitious, you'll start to realize that a lot of them are like repeated and are very related and interwoven. And as you start to realize that, you can see these different uses that might not be specifically stated, that you can take this technology and use it for that over there, and take that whole concept and these experiences that you're having of the technology of how the quartz water thing could be used with this one, and you make something totally better. Imagine doing that with all the space technology, or reverse engineering technology, or alternative energies, or exotic weapons, or exotic technologies in general. All of those, if you're some scientist or some general that's studying this stuff, you start to be able to realize that you can pick and pull bits of these technologies, and that they eventually become really related to one another. And yeah, I just find that to be really interesting. So green energy sources like solar and wind are generating more power as their infrastructure expands, but we need robust methods to store excess for later use. Solar power generation peaks during the day, but usage is highest after dark. Wind generation also suffers from the intermittent nature of airflows, making storage the key to harnessing the full potential of these renewables. Researchers at the University of Michigan have heeded that call and recently developed a cost-effective, highly efficient thermophotovoltaic cell that converts heat to energy. According to the outlet New Atlas, thermophotovoltaic cells absorb photons from the infrared part of the spectrum in the form of heat, whereas normal photovoltaics absorb them from the visible light. Energy created by clean resources can be discharged as heat into these cells and extracted as electricity again later. As the report detailed, the medium for storing heat could be anything such as sand, molten salt, or clay bricks, but the researchers' new system uses silicon carbide. It's surrounded by semiconductor materials, including indium, gallium, and arsenic, that are designed to maximize the range of photons collected from the heated source. And it's interesting they talked about the molten salt. Remember when we read the article about the nuclear power plants being used with molten salt? They were fission plants, but we're going to be talking about fusion, which is totally different in just a second. But when the researchers subjected the cells to a temperature of 1,435 degrees Celsius or 2,615 degrees Fahrenheit, semiconductors captured 20 to 30% of the energy exuded. Additional layers of air and gold reflectors work to bounce some escaped photons back to have another chance at being converted. The team eventually reached an impressive total power conversion efficiency of 44%, which beats the 37% achieved by other projects at the same temperature. Stephen Forrest, a contributing author of the study, said, "We're not yet at the efficiency limit of this technology. I am confident that we will get higher than 44% and be pushing 50% in the not too soon future." As the U.S. Energy Information Administration reported, U.S. electricity consumption is expected to grow 3% in 2024 and 2% in 2025. While electricity generation should grow by 3% in 2024 and 1% in 2025. Wind energy should remain around 11% of our renewable output, but solar is expected to grow to 7%. To try to help keep pace, at least one solar project using stored heat in a different way is already being implemented and specifically dealing with the intermittent nature of the supply. That project will focus on solar energy as a heat tower and use this heat to create electricity by powering a turbine. Some of the heat will be stored to power the turbine when the sun isn't shining. While systems that store energy as heat, including photovoltaic cells, may be less efficient than lithium-ion batteries, the researcher team believes that its tech is a better way in several ways. As New Atlas detailed, it's safer and cheaper to make and maintain, enough so that even losing some of the stored energy is still cost-effective. Forrest expanded on the benefits in a statement in Michigan News saying, "It's a form of a battery, but one that's very passive. You don't have to mine lithium as you do with electrochemical cells, which means you don't have to compete with the electrical vehicle market. Unlike pumped water for hydroelectric energy storage, you can put it anywhere and don't need a water source nearby." So that's fascinating, and that's good news. I'll just say real quick before we move on, I was talking about fusion and fission, and I mentioned fusion, and if you remember, they said that they had figured out fusion, and that, Princeton had confirmed it, and that they just could shoot an ion laser at this material and create a fusion reaction, just a sustained fusion reaction just by shooting the laser. So we have fusion right there. I mean, as soon as they said that, I was like, we have craft using that easily, hands down, right there. Um, but it seems like we have a lot of different technology that we're using. Uh, I don't know. That's just what I had thought as soon as I read that. But there's so many other things that point to that. It seems like we're still mastering it though, but it's coming into the public field, and it seems like it's definitely in the private field. But along the same line of going into public from the private field, it seems like researchers realize time reversal through input output indefiniteness. And it's kind of a tongue twister. It's kind of hard to even imagine, but Huang Rui, University of Science and Technology of China, a research team has constructed a coherent superposition of quantum evolution with two opposite directions in a photonic system and confirmed its advantage in characterizing input-output indefiniteness. The notion that time flows inexorably from the past to the future is deeply rooted in people's minds. However, the laws of physics that govern the motion of objects in the microscopic world do not deliberately distinguish the direction of time. To be more specific, the basic equations of motion, both classical and quantum mechanics, are reversible. Changing the direction of time coordinates systems of dynamic process along with the direction of some of other parameters still constitute a valid evolution process. This is known as a time reversal symmetry. So it's going the same things happen both ways. It's a symmetry of forward and backwards, is what it's saying. In quantum information science, time reversal has attracted great interest due to its applications in multi-time quantum states. Simulations of closed time-like curves and inversion of unknown quantum evolutions. However, time reversal is difficult to realize experimentally. To tackle this problem, the team, led by academician Guo Guangkang, Professor Li Chuanfeng, and Professor Louis Binheng from the University of Science and Technology of China and the Chinese Academy of Sciences, collaborating with Professor Giulio Chiribla from the University of Hong Kong, constructed a class of quantum evolution processes and photonic setup by extending the time reversal to the input-output inversion of a quantum device. When exchanging the input and output ports of the quantum device, the resulting evolution satisfied the time reversal properties of the initial evolution, thus obtaining a time reversal simulator for quantum evolution. On this basis, the team further quantized the evolution time direction, achieving the coherent superposition of quantum evolution and its inverse evolution. They also characterized these structures using quantum witness techniques. Compared to the scenario of a definite evolution time direction, the quantization of time direction showed significant advantages in quantum channel identification. In this study, researchers used a device to distinguish between two sets of quantum channels with a 99.6% success probability, while the maximum success probability of a definite time direction strategy was only 89%. The study reveals the potential of input-output indefiniteness as a valuable resource for advancement in quantum information and photonic quantum technologies. So that was a mind bender, and that was a lot of jargon. But from 89% to 99.6% is that's really big increase statistically whenever you're talking about these devices like that. And from what I can tell is that it's saying that, as people have said, that this is further evidence of the quantum nature kind of being outside of time, if you want to say it that way, or some sort of cyclical nature of it continuously going forwards and backwards identically. And One could interpret that mathematically as a fractal. I'm pretty sure. If I'm incorrect on that, I would love to hear anybody email me, because I'm pretty sure that that could be represented as that, like mathematically and visually. And so what will we find out about this stuff? This is like cutting edge stuff that the scientists are trying to understand. But the thing that it seems important to me is that if we're going to be trying to do these quantum communications with allegedly interdimensional type of beings, or beings that seem to be outside of our quantum dimension that we're in, or interfering with it, or maybe not interfering is the best word, but intersecting with it somehow, that we would need to understand these techniques, and understanding this concept would make it easier to communicate with these beings, because that's the type of nature that they're in, and that's the world that they are in. And yeah, from the sorts of experiences that I've had, this is like a really important concept, and something that will continue to come up is the flow of time forwards and backwards being the same, and that you can invert it and it will be the same. Seems like a lot of these beings will operate through this sort of stuff. And it says here simulations of closed time-like curves. So that kind of goes back to the fractal type of thing that I was talking about. But anyways, we will go on to cosmic oceans. Earth is crossing an ocean of mysterious dark matter. Here's how it's impacting our atmosphere.